Well, good morning. Good morning. I'm Yannis Yortsos. I'm the Dean of the USC Viterbi School of Engineering, and it is my great pleasure to kick off this wonderful meeting today. I wanted to welcome everyone to our 2018 Grand Challenges Scholars Program annual meeting. This year, we're celebrating the 10th anniversary of the announcement of the NAE Grand Challenges, as Dan Maud mentioned yesterday. And in a few months, in March 2019, we will also reach another milestone, which was the 10th anniversary of the first Grand Challenges Summit, which took place in Durham, North Carolina, and was hosted by Duke University, as well as the establishment of the Grand Challenges Scholars Program, which happened about in spring of 2019 as well. So much has happened since then. We had 5 Grand Challenges Summits. The last one happened here in DC last year. The next one is in London in fall of 2019. We had more than 100 schools that participate or intend to participate in the Grand Challenges Scholars Program. And the program has grown to become essentially a signature program for the NAE. I am indebted, and all of our initial committee members and many of the participating schools were very much indebted to the late president of the Academy, Chuck Vest, who endorsed and embraced this program from the very beginning. And of course, the current president, Dan Maud, who has spearheaded the creation of the NAE Coordination Office and has put the Grand Challenges Scholars Program and the Grand Challenges as an important part of the NAE initiatives going forward. It's worth taking a moment to understand the fundamental reasons that drive the Grand Challenges Scholars Program, and I will start with the Grand Challenges. And I'm asking the question, why Grand Challenges? And the fundamental reason for this, in my opinion, is that we live in these exponential technology times, where technology is moving exponentially fast. As Tom Friedman of the New York Times calls it, we live in the era of constant accelerations. These tremendous advantages allows us to address increasing complexity. So in this little slide here, I have a graph of technology. Those of you who are looking for units, do not look for units. This is just numbers there, both for technology and for time. So this is a dimensionless diagram, but I don't tell you what the units are. And because technology increases so fast, allows us now to tackle grand challenge-like problems. And it also enables the convergence of disciplines. And I should also mention one other thing, that because technology is so powerful, it also brings powerful unintended consequences. And this is where ethics become more and more important part of what we do. So that's something that it is not as much appreciated in our engineering education programs. And that's something that should be appreciated more and more because of the tremendous increasing power of technology. We're all familiar with the NAE Grand Challenges that were articulated in 2008, and they fall into these 4 buckets of sustainability, security, health, and enriching life. One way to view these Grand Challenges is to look at it as a Maslow's hierarchy of needs. So on the right, or your right as well, is the they call the pyramid. Actually, it's a triangle. I always argue with these people. And if you look at the Maslow's hierarchy of needs who apply to individuals, I will look at the NAE Grand Challenges as applying to society. And the issues that society also face include sustainability, security, just like individuals, health, and then self-actualization, perhaps let's call it enriching life. And with the risk of being kicked out of the academy, I also added another bucket, which I call societal organization. I think hopefully in a new iteration of the Grand Challenges that perhaps will be part of what we do, in the sense of we are also interested on social phenomena as well, and how the engineering and technology can deal with that. The fundamental question, though, is why engineering? Why is engineering the most important part for addressing grand challenges? It is because engineering is the enabling discipline of our times. I have difficulty articulating this to my fellow deans, non-engineering deans in my university, who think that I am too engineering-centric, but that's the reality. Engineering is the enabling discipline of our times. And human nature does not change exponentially fast, and technology does. So if you were to make significant changes and solve grand challenge problems, you got to use technology somehow. In fact, if I may say anything, in recent years, human nature not only does not change exponentially fast, actually we have noticed human nature going south rather than going, steady state or perhaps, increasing a little bit. So I think that this is a fundamental underlying reason why grand challenge-like problems articulated in many other disciplines as well will not be successful, really, unless technology and engineering is the fundamental underlying part of that. For instance, I have partnered with the creation of the Grand Challenges for Social Work. This was an effort that started in was announced in 2016. If you look at their problems, are very different than ours. For instance, stop family violence, advance long and productive lives, and homelessness, things that are very wicked problems, very human-centric. I believe that unless people use the exponential advances of technology, making progress in this fundamental wicked problems will not be able to happen. Likewise, people talk about the UN Sustainable Development Goals, which is over here. And I think Dan mentioned it yesterday. Many of these UN Sustainable Development Goals, again, will not be able to be solved unless engineering and technology comes into play. This is the reason why we believe that the Grand Challenges Scholars Program and the Grand Challenges of the NAE are the fundamental tenets, the fundamental challenges, actually, that can help solve a variety of other problems as well. So in this position, I am have very strong opinions about that, and I believe that we partnered with other organizations or other entities that want to advance grand challenge-like problems will be most successful if we are also becoming partners of those organizations as well. Now then, the question is, how can we address the grand challenges, the solution of the grand challenges? And one of the ideas that we had back in 2009 is to create a program that essentially tries to educate the generation of students and leaders that will be able to address the Grand Challenges Scholars Program. So the problems are timely, they're inspiring, and it is with the goal of helping talented engineering students attracted to this vision and preparing for their solution that we created this Grand Challenges Scholars Program. The traditional approach to engineering education relying on providing knowledge and skills in order to solve problems. So for grand challenge-like problems, the question, therefore, is how do we how do we prepare such students? And I believe that this requires not only knowledge and skills, but also new mindsets. And I will explain what I mean by that. So in the traditional way by which education is provided in brick and mortar universities, we essentially move in the horizontal axis between knowledge and skills. If you go back 20 years ago, 30 years ago, in most schools, in most universities, we emphasize how to get our students to receive some knowledge and also how they are trained in certain skills. But I believe at our times of exponential change requires to be adaptable, agile, and to be able to have mindsets, the creation of mindsets that allow us to deal with uncertainty, to deal with the complexity of the world, and also to be able to adjust. And therefore, I think that in brick and mortar universities, the way by which we deal with how we educate our students has to move from what I have there here, which is close to knowledge and skills, to higher, which is also different mindsets. And I call them mindsets of growth. There is Carol Dweck, who actually was invited to come to this event here today, talks about growth mindset, which is a psychological concept. I don't want to intrude in that domain, and so instead of calling it growth mindset, I call it mindset of growth. So mine is different than hers, and I will give you an example where the difference is. So the mindset of growth is actually moving along the exponential. So this is how I identify the mindset of growth that we have to be teaching our students, and be able to what I call in a moment, hug the exponential, stay with the exponential and move up. As opposed to a fixed mindset, which essentially is the tangent, let's say, to this particular technology curve. Human nature, humans are very good at extrapolating linearly, so most of the things that we do very well is to simply draw a tangent to this exponential. But in an exponential world, the gap between the fixed mindset and the growth mindset will become bigger and bigger because of the fact that technology is a nonlinear, grows in a nonlinear way, and this gap will materialize more and more. And so the question is, how do you change the culture in our organizations to go from a fixed mindset to a growth mindset? And that is the essence of the Grand Challenge Scholars Program. Dan mentioned yesterday that this is going to be a new model of education, and I strongly believe that this is the case. In other words, that we have to start training our students to have a different mindset of growth, rather than fixed mindsets, which will take you to a certain distance, but not far enough. So the Grand Challenge Scholars Program started in 2009 on the left. You see a younger trio. On the right, a little more senior trio, hopefully wiser. The only person who hasn't changed is Rick Miller, because Rick's hair was the same back in 2009 and 2016. And he told me that yesterday as well. So we cultivate 5 mindsets: research and creativity, multidisciplinarity, entrepreneurial, cultural and society conscious. I think that Dan mentioned it yesterday. This now is adopted by a number of schools. This number keeps changing, and so I think Rama will actually tell us exactly how many such schools are there today. And now it is supported significantly by the NAE. I should mention that this program is consistent with the World Economic Forum report on other attributes for the 21st century: creativity, leadership, perseverance, grit, things that we don't typically associate with engineering schools, but in fact it should be. And I think this is changing what we should be teaching in the schools of engineering. And also it's consistent with the engineering of 2020, which, by the way, is 2 years from now. And that's something that is an important note to make as well. So I will be closing by essentially rebranding, if you like, the 5 mindsets or competencies of the Grand Challenge Scholars Program that changes the conversation about engineering. So in terms of the technical skills, I call it hug the exponential. So this is the term that I use: superb technical skills and knowledge to lead the exponential changing technology. That is a fundamental thing, and it may be very well be 40% of these competencies, or even more, but it's fundamental to what we do as engineers. The second is this interdisciplinarity. I call it engineering plus. Change the conversation about engineering. Engineering plus X, where X is anything, and I truly believe that, particularly when X is human-centric. You're talking about autonomous cars, you talk about drones and other things. Who we are, what we do, and what we look like addresses also the diversity question. That's very important. And the Grand Challenge Scholars Program, I must tell you, it's a fantastic program, because more than 50% or 50% of the Grand Challenge Scholars, certainly in our school, are women. They are attracted to the program. They understand why this is such an appealing program for engineering and for impact on society. Third is innovation in the broadest sense. Innovation and entrepreneurship to help create the new markets, new jobs, and I will just go a little bit further and say to design the new self. In an exponential world, we have to reinvent ourselves every year. We have to reinvent the way our vision. We have to figure out what it is, how the world is changing, and how do we actually help to change the world. And I think that's part of the innovation entrepreneurship. The cultural mind, cultural awareness with culture broadly interpreted, whether it's both global, actually as local. You have culture that it is non-uniform across the United States in different parts of the world, of the country, and also, of course, different parts of the world. And what I call heroic engineering, I don't know if Megan Smith is here, but Megan has coined that term, heroic engineering, essentially the impact of engineering to society. I find this to be a wonderful term to use for how engineers help society in many different ways. And it is not simply only for having a business model that's successful, but at the same time to understand the impact of engineering to society. And the corresponding importance of technology ethics. So in a nutshell, this is my view of where we are today and where the program is going. And since my time is getting close to finish, I like to now